Sysdig is the first cloud-native visibility and security platform that eliminates the need for standalone tools like container security and monitoring. Using Sysdig's unique data approach, enterprises can solve a variety of visibility and security issues at massive enterprise scale for multi- and hybrid cloud environments. Sysdig will enable your organization to scan and block vulnerable images and enforce best practices pre-production, block threats, enforce compliance, and monitor application performance, proactively alert on incidents, reduce MTTR with forensics, and capture detailed audit records, all from a single unified platform. Accelerate your transition to containers and then have confidence in your ongoing operations using Sysdig. To learn more, visit securityweekly.com/Sysdig. Too many alerts and not enough action? It's time to get SaltStack. SaltStack is an intelligent IT automation platform that detects security issues in critical business systems and then actually fixes them. With SaltStack, security and IT teams work together to define custom security policies with certified checks for CIS, DISA-STIGs, and more. You can scan systems for millions of compliance checks in minutes. Remediate compliance and vulnerability issues with powerful automation, all in a single platform. Visit securityweekly.com/SaltStack to learn more.
Welcome to Security Weekly. I am your host, Matt Alderman. We are recording live from Black Hat 2019. We're in the suite at Mandalay Bay. Joining me is Mark Batchelor, Chief Solutions Architect with Ping Identity. Welcome.
Thanks for having me. Appreciate it.
So we're going to talk API security, and this is an interesting topic for me. So a little background, just so you understand where I'm coming from. My last company was a container security company called Layered Insight.
Okay.
And I've been doing research on the application side even since the day I was at Tenable. And this is a really interesting challenge I think we have as we think about digital transformation, the way applications are being built, and the proliferation of microservices, containers, et cetera, right? And so I want to start a little bit with the problem statement. You know, API security, first of all, I think we see APIs, the proliferation of APIs going crazy.
Yep.
I think there's a challenge with identifying where APIs are, let alone all the other things. So let's start with the problem statement a little bit. How does Ping look at this?
Sure. So Ping kind of looks at everything with an identity lens, right? And so not only just sort of discovering where the APIs are, but also the security around them, and not necessarily the raw security, but the identity security around who's accessing that API. Mm-hmm. How do you access that API? And then what are you doing when you are accessing that API? Right. So for Ping, pretty much everything has an identity lens, and that's the lens that we look at it through.
Yeah, and if you think about it, right, each API needs to authenticate to something, right? But how do you know where those APIs are to know whether they're being controlled by Ping's authentication solutions, right? I mean, that's got to be one of those first interesting challenges, right?
It is. So what's interesting about APIs for me at least is that much like websites used to be, if you go back 10, 15 years, they might just pop up. Right, and they weren't necessarily in sort of a realm. It's the same thing with APIs now. It's not rogue, but you might just see an API show up in an enterprise somewhere that some developer wrote and kind of started using it, right? So you get that kind of shadow IT thing going on for APIs, and there isn't necessarily a lot of security around it. So what a lot of companies have done is they've put API gateways in place, right? But you're only as good as the APIs that your gateway is managing, right? So if APIs are showing up somewhere else, what do you do about it, right? And we have a couple of products that can help with that. Specifically, one we call it Ping Intelligence, which we did an acquisition last year of a company called Elastic Beam that does some of that in the space, right? So a little bit of API discovery, a little bit of artificial intelligence around APIs to figure out how to secure them in general. Does that make sense?
Yeah, because you're right. A new application or an existing application and a new function spins up a brand new microservice because it's containerized. It comes up, and now there's a whole bunch of new things communicating to that API endpoint, and nobody knew it was there. Right. And it's happening daily.
Without question.
It's not like the old waterfall approach where, it would take a few months or whatever to get a release out. I mean, this stuff could happen on a daily basis. And so one of the big challenges I see with API security is just knowing where all those new API endpoints are.
Right. Well, not only can it happen quick, but it can happen without you even knowing it, right? So you may be running a vended product that you upgrade, and now there's a new API endpoint available that you were unaware of.
Right.
Right. So that's entirely possible. And I don't know what the statistics are around it, but some of the biggest attacks in the last 5 or 6 years have all been around APIs for the most part, right? So
Yeah.
it's important to be able to figure that out. Right?
So some discovery capabilities. I assume across multiple platforms, because where I see the proliferation is probably 3 primary places. In the cloud.
Yep.
Right? You've got a lot of API communications in your cloud environments now.
Yep.
Your core applications have a lot of API endpoints.
Yep.
And if you're doing mobile into those, there's a huge footprint from a mobile back to app kind of communication, right? Are those the 3 primary buckets? Are there more?
Those are basically the big 3. So the way we look at it and the way our product is kind of tailored, right, is we're tailored for the enterprise, right? So the enterprise may have their stuff running in Amazon or Google or Azure, right? And we can sit in front of that to protect it, right?
Okay.
They may be sitting on premise, whatever it happens to be. It could be a vended product, could be their own, right? We can sit in front of it there. And we run in a couple different modes, right? So we can run as a proxy and sit in front of a bunch of stuff, and that's how we can do discovery, right? So you force API traffic through it, and we can see new APIs as they come up, right? Report on them, and you can decide what to do with them. Or the other mode that we run in, and arguably more popular mode actually, is that we run as a sort of a plugin to other gateways, right? So you may have deployed already. Pick your large gateway vendor of choice, right? You may have already deployed it. We can plug into that, and they consume our AI engine.
Okay.
Right? Does that make sense?
Yeah.
Yeah.
All right. So now I've got all my APIs discovered. I know where they all are. Okay.
Yep.
Problem 1 down.
Yep.
Now what? Right? And now it's all about detecting potential attacks across those API endpoints. So now where does Ping kind of step in and start to look at aspects of the detection problem?
Yeah, so the way we do that, regardless of whether or not you're in gateway mode or running as a proxy mode, right, is we have an AI engine that we run that is on-premise in this case, right, or in your cloud, right, and we'll run in discovery mode, let's call it, for however long we need to run to gather enough data to figure out what is normal for your APIs.
Yeah, so you're doing behavior analysis of the APIs under kind of just run it, let's see what it does, and baseline it.
Right, it's unsupervised learning at this point, right? So we're just paying attention to it, right? And then once we've decided that we have enough traffic, right, we've seen enough of the API traffic to make a informative decision, we flip over to supervised mode, right? And once we're in supervised mode, then we can start blocking, we can start informing, and we can start doing a whole bunch of different reporting so that, let's say, a stolen token attack is happening. So someone went off and stole an OAuth token, right? And they're trying to reuse it. We can detect that now because we saw it the first time when we issued it the first time, right? The second time around, it's coming from somewhere else. We can detect that and block it, literally stop that traffic from happening. And we can do some really interesting stuff. We can detect slow attacks as well, right? So just because we paid attention to the behavioral, and that's also what lets us do some of the detection for new APIs is that we've never seen it before. What do you do with it, right? So block it. And then once we set it up, you're good to go.
Yeah, you block it, and then the developer screen because you just blocked their new API endpoint. You're like, oh, okay, that's you. So let's put that into the inventory. Now let's monitor that for a period of time and understand its behavior, and then start to look for anomalies across those behavior baselines.
Right, and the behavior piece is really the interesting portion of it, to me at least, is that, let's say, for example, you have a banking API, right? And it's normal for somebody to check their account, maybe transfer some money, maybe log out after that, transfer from account to account or something like that, right? But it's not normal for that same person to, log in, transfer a whole bunch of stuff, a bunch of different places, and then come back out. The pattern in which you use the API actually makes a difference too, right?
And can you monitor it down to that user endpoint layer or not?
Not yet. So to the specific user, not yet. We're working on that, but not yet, right?
Okay.
But we can monitor the traffic pattern. So my banking app, right, generally does these things, right?
And so when you see something malicious in the normal behavior of that app, that potentially flags something, but you can't do it on an individual basis. You're looking at it from an application endpoint, API endpoint perspective.
Yeah, and maybe a bad actor's not using the app; they're going directly after the APIs. The pattern in which they do it is generally different from what the app would do,
Got
right?
it.
So we can detect that kind of thing.
Yeah.
Right.
Okay.
Yeah.
So alert, I imagine.
Yep.
Block.
Yep.
A lot of people blocking or no?
A lot of people. Yeah.
Really?
Yeah. It's funny. Certainly you end up with some false positives in the beginning, right? Once you flip the switch, it just is the nature of the beast. But most people want to ultimately end up at a blocking state, right? At some point.
Yes,
Yeah.
I agree.
Yeah.
It just usually takes time, right? You got to build that level of trust. Make sure you get the false positives out of the system, because what we're dealing with here are primarily critical applications. You're talking to enterprise customers, right? So by blocking, you don't want to block something that's valid because you don't want to break the application.
Right. So people are getting there with it. Let's put it that way, right? They all want to get to a blocking state. Some are there, and in general, many are reporting at the moment. So,
good. Yeah, and then obviously all your reporting requirements and the other things that you need to track and trend are all there.
Right.
Any integrations with the DevOps teams and tools today? Because if I think about developers, right, they're developing code, they're releasing code, it's out in production. You guys are monitoring aspects of what's going on. Some of that data might be interesting to the DevOps team. Have you thought about how that potentially closes the loop back with the DevOps teams, like looking for malicious endpoints or functionality of those endpoints that the developers didn't really know existed and shouldn't be there? Have you done anything there yet or no?
That's an interesting question. Not yet, right? We have a ping identity in general has a DevOps story, but it's not necessarily around protecting the DevOps environment or protecting that pipeline. It's more about how is our software DevOpsed, right?
Oh, yeah.
So in that space, look, if it's an API, we can protect it and figure it out. If it's not an API, we're not really looking at it today.
Got it.
Yeah, makes sense. Yeah.
So customer, how's deployment? I mean, you said the AI engine's on-prem today.
Yep.
So what's it take to get this environment set up and running? Some plugins to the AI engine or your proxy, and that's pretty much it?
Well, it depends on how you're deployed, right? So we have the way we break it out is one is inline mode and the other one we called sideband mode, right? Inline mode, as you can imagine, we're a proxy, right? And we're proxying all the API traffic, and as we proxy it, we can do some really interesting things, right? That's when we can do some discovery, right? We can. There's a bunch of caching. There's some interesting things we can do as a proxy, right? Sideband mode is the easiest to deploy, right? Simply because, most shops already have an API gateway of some sort, right? And they've already doubled down on the fact that they're shoving most of their stuff through pick your API vendor choice, right? Whatever it is. In sideband mode, we've done most of the integrations. We've had some of them do the integrations. We've integrated with most of the major vendors at this point, and they offload the blocking decision basically to us.
Okay.
So they send traffic hits them. They offload it to our engine. Our engine gives them back a decision. Right. And then they do the block.
Got
it. In that mode, we've got a couple of different things that have to be deployed. One is the AI engine, right? One is our data lake, right? Because we have to store this somewhere, right? And then we've got our proxy that runs in non-proxy mode, basically, that does a bunch of that data, right?
Got it.
So make sense?
Yeah.
Yeah.
Perfect.
It's not a hard deployment.
Yeah, and if you're doing the proxy, then all that other stuff's embedded in there. Your AI engine and the data lake's all part of your proxy. But when you're doing the side channel, you've got to integrate that all into the AI engine and into your data lake to do all that decision processing, et cetera.
Yep.
Awesome.
Yeah.
From a value perspective, where's the value to the customer by implementing Ping's API security?
Wow, that's a great question. Well, first and foremost, we've seen a couple of different things, right, from our customers, right? Some of them just immediately get it and they go, well, I have to have that. And in general, it's kind of the reporting piece they want to see up front, right? It's, I want to put this thing in front of my APIs and see what's really happening, right? And then we've had, certainly somebody may have had a breach, right? And now they have to do something about it. And when that happens, the value's obvious.
Yeah, right.
Yeah.
Yeah.
So our customers today, they all look at it and go, wow, we need this, mostly for visibility, but some of them actually need it because something bad happened.
Right.
Yeah.
Yeah.
So, yeah.
And to me, it's around visibility.
Yep.
And then ultimately control.
Right.
Right.
Yeah.
And if you can prove value on those two dimensions, then you've built a great product.
Absolutely. Yeah.
If people want to learn more, where should they go?
Simple. Pingidentity.com.
Awesome.
Right. Yep.
Thank you, Mark. Thank you so much.
Yeah. Thank you very much
me.
for your time. Appreciate it.
And with that, we'll take a break and come back and see you soon. Welcome to Security Weekly. I am your host, Matt Alderman. We are recording live from Black Hat 2019. We're in the suite in Mandalay Bay. And joining me for this interview is Ameya Talwalker. He's the co-founder and chief product officer from Cequence with a C Security.
Yeah.
Welcome.
Thank you. Thanks for having us.
Yeah, it's awesome. I think we've had you on. I think we've had Cequence on before.
A few months ago.
Yeah, I think so.
It was
Yeah.
late last year, I think.
Yeah, it was. I think we were talking specifically around the bot side,
Bot side.
bot defense. We're going to talk a little more about application security, one of my favorite topics. I always like to preface, the audience knows this by now, is I'm a believer that there's three things that matter when we're done with digital transformation: app, user, and data.
Yep.
Right? So I love the application security topic extremely well. Let's start with the problem statement. The title, the topic that came across is, why the hell is application security broken? Why the hell is application security broken?
So it is a little bit of a bold statement, but I think this is based on past experience. We've been working with large enterprises for 5+ years now, protecting their applications from various kinds of attacks. And we've seen a few trends emerge, right? Which is the way enterprises are building their applications, deploying their applications, where they are being deployed. It's all changing very fast, very rapidly. The attackers on the other side, which want to attack these applications, are also evolving very fast. Their infrastructure, their tools, easy access to credentials and other materials that they need is getting easier and easier. So on the two sides, you have the applications and the enterprises are changing very rapidly.
Right.
The attackers are also changing very rapidly. And the security tools that sit in the middle are sort of, progressing very slowly. So they haven't kept up with changes on either sides. And that's why we think that application security is broken.
Yeah, and I tend to agree, right? I think there is a lack of integration of security tools and capabilities embedded into the development process or the DevOps process. We talk a lot about DevSecOps, but I don't think that a lot of us actually understand what DevSecOps actually means and what it takes to get there. So I'm a big believer. You have to definitely look at integration. And if we think about the traditional application security tools, they're always kind of at the end of a process, right? I do a static analysis, I do a dynamic analysis. They're always kind of after the fact. And I think the other challenge is speed, frequency, right? I mean, you can change an app daily or multiple times a day now.
Yeah.
We're not used to doing stuff that fast.
Very true. And I think we see that in several of our customer environments. Like we have a customer that updates their web, mobile, and API apps once a week.
Yeah.
If sometimes twice a week.
Yeah.
And if you are forcing security to be embedded inside the application, that's going to slow down your DevOps. So the whole notion about DevSecOps should be as fast as DevOps just goes away once you force anything inside the application for its security.
Got it. So let's talk a little bit about Cequence, because you've got your application security platform. You have different components that sit on there, right? You have the bot defense capability, the firewall capability. We're going to get into that. You also have your kind of core engine as well. So let's talk about the Cequence solution, the platform.
Right.
Kind of give us an overview of what's all there.
Right. So Cequence has built a platform called Cequence Application Security Platform, CQASP, that gets deployed completely in our customer's environment.
Okay.
Right. So first of all, it's not a SaaS service. It's not a appliance that we deploy. All of this is completely deployed through containers that are, living in our customer environment.
Okay.
Right. We are not taking data out to do an offline inspection and analysis that takes a while, and there is an offline, off-the-band communication. All of our solution, the Cequence ASP platform, gets deployed in the customer environment, whatever that environment may be. So we have deployed our solution in physical data centers. We've deployed it in cloud environments. But most commonly, what we find, and this is one of the things that I mentioned when I said the enterprises are changing, a lot of enterprises are still in their hybrid state, which is some applications are running in my physical data center, some are running in the cloud, and I need to secure all of them. Right. I need a solution that can secure all of them.
So in that particular case, are you deployed in both of those environments, on-prem and in the cloud?
Right. Yes. So parts of our solutions, which we call as sensors and enforcers or mitigation, sit very close to the application. The CQ AI engine, which is really the brains of the system, can sit either on-prem or in the cloud.
Okay.
As long as it's connected to all these sensors and enforcers right close to the application. So the way we look at it is the platform has the analytics engine, the CQI engine. It has connectors to other enterprise security solutions like a SIM system or a fraud system, or we enforce things through a WAF or an IDS and IPS. So all of that is sitting in the environment away from the apps, or almost parallel to the applications. And then we have sensors which sense the data from sitting in front of the application. And we have enforcement modules that will either block, slow down these attacks, or we have even capabilities to deceive the attackers with what we call as honey trap, which lies back to the attackers and makes them believe that they are getting successful.
So platform deployed, got the core CQ AI engine in it. Then bot defense and then the firewall are actually the sensors, right? The sensors and the enforcers.
Right. And that's one of the problems we are solving, which is you have too many point products that are trying to solve a single problem for customers.
Which is application security.
Right? You have your bot mitigation solutions. You have your web application firewalls. Maybe now you have a new product that is only solving API security. So it's hard for security operators or professionals to manage all these solutions. So what we have built is a single pass architecture where we just look at a transaction once and look at it from multiple problem point of view, right? Whether it's a application security problem using OWASP or other type of syntactic problems, or is it causing a automated threat which is bot attacks, right? So our goal is to provide a single platform that is solving multiple problems for the entire application tier, wherever that tier is.
So are your sensor and enforcers multifunctional? So
yes, they are.
The sensor's grabbing the data, and then you're looking for bot traffic in that. You're looking for potential any firewall rules around your web app firewall. Are you also doing things like API security? And so all that's collected through that sensor. I can look across all those different domains.
The CQ AI engine is what's looking at each transaction from a different point of view. Right, the sensors is just grabbing sensing the data. Right, and the CQ AI engine forces or enforces whatever policy action the customer wants to enforce for a given type of threat.
And so then policies are written on the platform, on the platform. Leveraging data from the AI engine. And then the enforcers are there to enforce those policies out in the application.
Right. And sometimes the enforcers are not required. We have customers who are taking our data and signaling their fraud systems. Right. We have customers that are taking our data and sending data to their accounts team. Let's say we are solving a problem of fake account creation, which is very common in social networks and whatnot.
So you're not enforcing anything. You're using more as just a detection capability to other teams. Say, look, this looks odd. Somebody's creating accounts or something like that.
Right. And therefore, deploying the enforcement piece is completely optional. Right. We believe, especially with the honey trap, we have a unique way of stopping some of these threats. If you keep blocking, automated threats like bot attacks, the attackers keep evolving and they'll keep coming back at you with different techniques and different networks and things like that. So therefore, the honey trap that we have is very effective in gaming the system or gaming the attackers and making them think that they're successful while you protect the applications from.
So you have some deception capabilities built into the platform as well, right?
Yeah.
So if you think about it, you're using the trap to actually deceive the attacker.
Absolutely.
Yeah, and probably collecting a lot more intelligence about the attacks
Absolutely.
that you can now use to potentially thwart other types of attacks, right?
Exactly.
Okay. So I want to get into the AI engine a little bit, right? Because when everybody hears AI or ML, they cringe for a second. They're like, oh, here's another one. Let's talk a little bit about what that engine's doing. Let's get to some interesting kind of hardcore examples, because I think it'll help people understand what does that engine actually do? How does it work?
So our AI engine works at multiple layers. So we are looking at application security, but we start looking at every request from its TCP/IP signal, looking at the SSL signal, we're looking at the application headers, and we also go all the way to the user layer and analyze, right? So therefore, there are different AI models that are working at different layers in our AI engine. Just to give an example, when a login request comes in for coming with the user agents that says this is a request from Chrome browser 65 running on Mac OS 10.5, right? Our AI engine actually validates that it is really what it claims to be.
Oh, okay.
Right?
Yep.
And it does that by analyzing signal at each of these layers, right? Therefore, we can say this is probably coming from a toolkit that is faking to be a Chrome browser running on Mac OS.
Got it. Okay.
Right? But that's not the only model. There are several others.
There's lots of models. Right.
So some models look at user behavior. Some models look at infrastructure behavior. Some models are purely working on statistics, right? Looking at patterns of transactions and volumes of transactions throughout the day.
So you're doing behavior analysis across the various layers,
Yeah.
right? I mean, all the way from the network layer, all the way kind of up to layer 7 at
Correct.
the application layer. So you're looking at different behavior patterns across all those.
Yes.
And then that's what allows you, it's probably mostly all unsupervised kind of mode stuff, right? Learning. And then based on policy, then now you can start to enforce across those different layers when you see malicious or abnormal behavior.
And customers have sensitivity towards certain types of attacks. For example, when you're dealing with fake account creation problems, enterprises don't want to block somebody from creating an account, especially if they're a social network, right? It hits their KPIs and things like that. So they want to let that account get created, but have a signal sent to either the fraud team or the accounts team to review these accounts that we think are created using bots.
Right.
So therefore, the options that we have on responding to these attacks is really powerful in our platform, which is not all attacks need to have the same solution or same response.
Yeah, not everything has to be blocked. Sometimes you allow it to happen, but you alert with additional data to say, by the way, we think this is potentially a malicious account. You might want to research it a little more, decide whether you want to keep that account or not.
Yeah, exactly.
Yeah, and you can do that across various types of activities.
Yeah.
It's great. So if somebody deploys Cequence, what's some of the value they can get out of your solution?
Okay. We typically, especially when you're talking about bot defense, we are not selling vitamins, we are selling painkillers. In most cases, we see customer is already suffering from massive account takeover problems. And there are various ROI models where if you're losing one account in a financial industry, the value of or the cost of dealing with that is around between $1,000 to $1,500 per account getting compromised.
Okay.
If you're dealing with, if you're a retailer, and you could be dealing with the denial of inventory problem, which means you're not able to sell items to your customers, right? You could be dealing with brand reputation issues where you want to sell something that is very limited in quantity, high in demand. So your real customers are not able to buy those things. Instead, the bots are shopping all those items. So you have a customer satisfaction, brand reputation problem. You could be subject to scraping information from your competition, in which case you're losing IP, right? So there are very, very, very simple, straightforward to understand ROI models that we work with our customers.
Yeah, I think the stat we talked about a couple months ago is like a third of all internet traffic is bot traffic now?
Half of the internet traffic is bot traffic and increasing, and 1/3 of the all internet traffic is bad bots.
It's bad.
So you have to also account
Right,
for
okay.
good bots,
Good bots.
which are Google Assistants and
We have
various
good bots and bad bots.
yeah.
Okay. Yeah. So 1/3 of all internet traffic,
is bad
malicious bots.
Yes.
So just from deploying the bot defense solutions, you can really start to minimize
Right.
malicious bot traffic to your applications. I mean,
Absolutely.
that's a value right there.
Absolutely. Yeah.
Okay.
Yeah.
Now let's get into some of the other value, right? So I get 1/3 of that malicious traffic out. Boom. Great.
Mm-hmm.
Okay. Now where's the rest of that kind of value sit? I think I know where it is. I just want to
Yeah.
hear it from you.
So a few other things to consider. Bot attacks are typically, voluminous. So in the sense you have millions of transactions hitting your web application tier or application tier. If you take all of those transactions all the way to the application tier, you are over provisioning your infrastructure by a massive amount, right? So there is a savings to be had on the infrastructure side by stopping these bot requests at the perimeter,
Yeah.
right, away from the application. So not only do you save from all the fraud-related costs, but you can also save on the infrastructure,
Right.
right? When it comes to app firewall, I think that is something that is very well understood, right? You're going to get a compromised application. Somebody's going to have a foot in the door inside your application tier.
Right.
You could be losing, account information, customer information,
right.
what have you, right?
Yep.
So that is a very, very well understood ROI
Right.
from the app firewall point of view. The bots thing is new, but it's also extremely painful for customers to suffer from.
Yeah, that's why you say it's a painkiller. It's not
It's
a
a painkiller.
vitamin.
It's not a vitamin.
Yeah. Just as long as you probably want them to get a little opioid addicted on the painkillers, though, because it probably helps your business model a little more. But yeah, I mean, both from a malicious activity, but also performance and cost savings on infrastructure.
Right. I mean, if you have excessive bot attacks, then it also leads to application level DDoS, which is not the network level DDoS,
right?
And that can mean you're not just able to serve your customers.
People can't log in, people can't buy stuff, etc.
That's when you make the news, basically.
Right, exactly.
You don't want to make the news as a CISO.
Yeah, right, exactly. If people want to learn more about Cequence, where should they go?
Simple thing, they can just go to cequence.ai and learn a lot of things. We have plenty of resources, white papers, case studies, and things like that.
Cequence with a C.
Cequence with a C.
Not an S. So
Cequence.ai.
Cequence.ai.
Yeah.
Ameya, thank you very much for joining us.
Thank you very much. Thanks for having us.
And thank you for joining us. We'll take a break and come back soon. Welcome to Security Weekly. I am your host, Matt Alderman. We are recording live day 2 at Black Hat 2019. We're in the suite at Mandalay Bay. Joining me for this interview is Michael Krueger. You are the Technical Services Lead and Senior Mobile Security Analyst at NowSecure.
I am.
Welcome.
Welcome. Thank you.
So we're going to talk mobile apps. My background is a lot container security and application, but I didn't spend much time doing things around mobile apps. So let's start first with some of the challenges around mobile applications.
Okay.
First, just in some of the nuances between maybe, a mobile app versus, a web app or something like that. Just kind of set the tone for us first.
Sure. So mobile applications, a little different, right? Like they operate on a handset. So everybody kind of thinks web app. Okay, desktop. I know the platform. I know what I can go after. I understand it. It's been how many years now that web apps have been around, right. So it's a known entity. Mobile, it's new, it's evolving. The platforms are evolving a lot faster than anything we've ever seen before. And it's a new entity, but the interesting thing is it's 50, 60, 70% of the market now, and it's only increasing. So that's the challenge, is just keeping up with the new technology, keeping up with the new demands for mobile, and how do you secure that as part of that?
Yeah, and each of the mobile platforms are a little different from a security perspective. Like iOS and the way it kind of isolates applications are different than on Android, for example.
Absolutely.
Right? And so when you're thinking about developing an application, putting it into an app store, if you put it in the Apple's app store, it has certain capabilities, and if you put it in a Google Play, for example, for Android, it's different there because they run differently on those different platforms. That's a challenge too, right?
Oh, absolutely. And then you think about Android in itself, the platforms are different. You've got how many different types of handsets here in the US, around the globe. You've got Android appliances, boxes, those sort of things as well. Those all run mobile apps, but all of their intricacies are slightly different. The way that data is stored on it, the way that data is accessed on it, the way that you as a user would view that or operate that's drastically different from, say, something on a Apple device.
Right.
So
Do you do testing the same on a mobile app than you would a web app? So in the world of web app, right? You do you do a static analysis of code. You might throw it into put in runtime and run a dynamic scan against a kind of black box, or you'll do an interactive, or do you do the same types of tests, or are they different for mobile applications?
So I think the concept is the same, right? You still want to do the same things. You want to statically analyze code, or in our case, binaries. You still want to dynamically test. You want to use it. You want to see where you can create edge cases, how you can create issues in the application. But the tests themselves, yeah, they are different. They hail from the web app sort of mentality, but they're definitely different, right? You have to think about with mobile apps, you have to consider that the platform on which they run to be compromised. You have to assume that, and I think with web apps, you don't have a lot of control over what it runs on. You don't know necessarily. You kind of you assume that the browser takes care of that security.
Right.
With mobile, that's not the case. You have to assume that the environment is hostile. You have to assume that the handset is completely compromised. And you take that mentality, and that's how you start your testing.
Got it. Because if I compromise the phone, I potentially can compromise other things if I'm storing them locally on the phone, for example.
Absolutely.
Right? So biometric hashes, if you're using biometrics for authentication, or password hashes, or other types of things that you would store locally, could be easily compromised on a mobile, and therefore potentially compromise the app, which is a little different than a web app, right?
Absolutely.
Even though we have lots of examples of doing that on web apps too.
Exactly. And that platform that travels with you, inherently, it's a mobile device.
Right.
So you're exposing that to a much wider environment where it can be lost, stolen, or otherwise compromised physically too.
Right. All right, so let's talk about NowSecure. How do you actually help people with mobile testing? What are those different solutions that you offer, and how do they work for people that are looking to do aspects of this?
So NowSecure offers a wide suite of solutions. So we offer a couple of cloud-based solutions that are completely automated security testing. So we like to focus on that because what's one of the hardest problems with testing is just manpower, time, depth of coverage, all of those issues that come into it. Well, we focus on how can we automate that? How can we go deeper without having a man in that loop? How do we go faster without having somebody in that loop? And so that's where our platform, our NowSecure platform, really focuses on. So it's completely automated, but it's also real devices that we test on. We have.
Oh, got it.
Yeah,
so you're actually taking their code,
we are
putting it on various types of devices, and then running different scans against them to see how they perform and
absolutely.
hold up?
So we actually installed their app on our platform on one of our devices. We have an intelligent agent that runs it without anybody touching it. It runs it. And while it's running it, while it's operating it, it navigates through the app, it clicks buttons, it enters text. While it's doing that, a slew of tests are being performed in the background. Dynamic tests, we're running static scans against the code that has been uploaded. We're doing all of that automatically.
That's really nice because, testing's a pain in the butt.
It is.
It is. And then you get this big report at the end, and you hand it to the developers, and you go, okay, here's all the things you need to fix. But if you can automate a lot of that and then hand that back to that team pretty quickly, probably makes that cycle a lot shorter to get their applications tested and up into the stores. Which is where they need
Absolutely.
them.
And let me tell you why developers like it. It's actually built in to their development cycle, built into their CI/CD process. So when they cut a new build, when they create a new version of their app, it can be automatically sent to us, tested, and all of the issues that we find automatically sent back into their bug tracking system.
Perfect. We just did a segment right before this on DevSecOps. And I'm a big believer in integrating security into the DevOps pipeline. But if you don't do it right, it's never going to get adopted. And that is
Absolutely.
make it really easy for the developers to use the tool, whatever it is, and make sure that the results are integrated back into their tool set, whether it's Slack or HipChat or Jira or what other
have you.
bug
Yeah.
tracking system they have, because then they'll get the data available to them. They're like, oh, yeah, I got to make this fix. They send it back through the pipeline, automatically goes through, no more bugs, they're done. And it's already past security,
Exactly.
and the security team's not giving you this big 300-page report on the other side.
We don't want to be the no team. We want to be the how do we enable you
Yes.
to get stuff done.
That's awesome. What about, so you said the cloud solution,
Correct.
but there must be some other tools?
Yeah, so we also have an on-premise solution as well. Not everybody is able to, we have a lot of federal clients as well where they're just not able to send their applications to the cloud, right? So
Right.
they need another solution. So we actually offer a couple of different on-premise solutions, that automated solution as well.
Okay.
We do offer an on-prem solution, and then we also have a deep dive self-contained kit. And that's actually how I came to the company, was learning about that kit. So I was actually a customer long before I worked at NowSecure.
So you move, as I would say to some people, you move to the dark side.
I did, but it's been the best move ever.
Awesome. How is it priced? I don't know. Is it priced based on number of mobile apps? Just how do people buy?
It is. It's based on number of apps tested,
Okay.
The frequency of testing. So we have a lot of different bands that we price out, but it comes down to how many apps do you have? How frequently do you want to test
them. Okay.
Exactly.
Perfect. If anybody wants to learn more, where should they go? What resources do you want to point them to?
Like to tell them, go to nowsecure.com. We have a slew of resources there. Anything you want. We've got blog posts. We've got webinars. We offer all of that free of charge. We've got a couple ebooks up there. I should point out that we do sponsor 2 open source projects, Frida and Radare.
Okay.
So we're a big proponent of open source. We want to,
Give back to the
we want to
community.
give back to that community. We want to support that community. We want to stay involved in the community. So I would say definitely check out those resources. Find a ton of information there, and there's a way to get in contact with me. There's a way to get in contact with anyone at NowSecure through that website as well.
Awesome. That's great. Thank you, Michael, for joining us on
Thank
Security
you.
Weekly.
Pleasure.
Thanks for joining us, and we'll see you soon.